What are the keys to being successful when we're working with division of decimals by a whole number? I came up with these 3 keys that will help us to have the best chance at getting the correct answer here. If we look here, number 1, we need to make an estimate. Number 2, we will then ignore the decimal and divide as normal. Step number 3, using your estimate, we can place the decimal back in the quotient. Let's take a few minutes and work through 2 example problems together to see if we can figure this out. Now my first problem is 25 6/10 divided by 4. Now I already wrote my problem. In both these examples I'll be showing partial quotient. And first I would like to come down here to the bottom. Now this right here, you might have seen this before. This is a box typically set up for what we call a magnitude estimate. Okay, and I'll show you how this works. You take your divisor, which is a 4, and you multiply it by each of these numbers. So you do this times 4, and a 1 times 4, and a 10 times 4, and 100 times 4. And then you write your answers up above. So we have 4 times 1/10, that would be 4/10. 4 times 1 is 4, 4 times 10 is 40, and 4 times 100 is 400. Now here's how we use this. So now we look at our dividend, the number on the inside, and you ask yourself, will 4/10 go into that? Absolutely. Will 4 fit into 25? Absolutely. Will 40 go into 25? Oh, that looks too big. So since this is too large, we cross that out. It also means that 400 certainly won't fit in. And we choose our largest number down here, which is the 1 or the 4. And this tells me that my answer will be generally in the 1's place. Okay? Now there's another way to do this. The second way to go ahead and do this would be if we look up top. We have 25 6/10 divided by 4. We are going to estimate by turning that 25.6 into a number that 4 will fit into and be quite friendly. So we may take 25.6 and make it 24. Now this doesn't follow a basic rounding rule, but with division we're just looking to get close, and the best thing to do would be to try to use friendly numbers, so numbers in the same fact family. Okay, you might also have decided to turn it to 28. Both 24 and 28 are close to the 25 6/10. Alright, and they're very friendly facts to work with. So now when we do 24 divided by 4, we get 6, and when we do 28 divided by 4, we get 7. So this just confirms what we mentioned down at the bottom with our magnitude estimate, that our answer will be in the 1's place. Okay, so now it's time to divide. So what we need to do is we need to just pretend that that decimal isn't there. So we cross it out. Now we just divide as normal. Does 4 go into 2? No. Does 4 go into 25? Yes, it does. It goes in 6 times, so that would be 24. Alright, but we have the 0 here. That needs a number, so we add a 0. So we add a 0 out here to our partial quotient. We subtract. We get 16. Will 4 go into 16? It absolutely will. Goes in perfectly 4 times. Now we tally up our answer, and we get, I'm going to write it over here, didn't leave myself enough room, we get 64. But remember, both of our estimates said that our answer will not be that big. So we need to come back in and we put our decimal point to make it in the 1's place, or make it somewhere around 6 or 7. We put it in, and our answer is 6 4/10. Our second problem is 6 75/100 divided by 5. Again, let's start with our magnitude estimate. We take our divisor and we multiply it by each of these numbers. And and 5 times a tenth would be 5 tenths, 5 times 1 is 5, 5 times 10 is 50, and 5 times 100 is 500. Now we compare this up to our dividend, or the number on the inside, and will half go into 6 and 75/100ths? Absolutely. Will 5 fit in there? Absolutely. Will 50 fit in? No, it's going to be too big, as will the 500. So again, our estimate looks like it's going to be in the ones place. Now let's go up top here and take a look. So now I have 6 and 75/100ths divided by 5. So if I estimate that 6 and 75/100ths, we could round it to 10. Now the reason why I chose 10 is because I know that 5 goes into it very nicely and goes in 2 times. Or we could use 5, knowing that 5 divided by 5 will give us 1. So both estimates support that our answer looks like it's going to be pretty small, but it's still going to be in the ones place. Now we're ready to start our problem. So ignore the decimal, I'm going to cross it out. And let's look here. I see that my 5 goes into 6 one time, so that'll put a 5 here. And I have 2 numbers that don't have anything underneath them, so I need to add 2 zeros. So it actually means 100. We subtract here, and we get 5, we have 7, and a 1. I look, and 5 will not go into 1, but it will go into 17 3 times, so I write 3 times 5 is 15. Now it looks like I have an empty, so I need to add a 0 there, and whenever you add a 0 on the inside, you need to add a 0 to your partial quotient. After subtracting, we get 25, and I know that 5 times 25 gives me 25. So it looks like we're done. If we add up our partial quotients, we get 135. But wait a second, both of our estimates said that our answer should be in the ones place, somewhere between like 1 and 2-ish, most likely. So now that means I have to go in and insert my decimal point, and I get 1 and 35/100ths for my answer for 6 and 75/100ths divided by 5. Let's take a look at some questions that have a 2-digit divisor now. Now again, let's start with our estimating. I'm actually going to start up here at the top where we have 38 and 4/10ths divided by 12. So I'm going to estimate my 38, that's basically 40, and my 12, that's basically 10. That becomes quite friendly, and 40 divided by 10 gives me 4. Now let's come down and do our magnitude estimate. So again, remember from just a little bit ago, we're going to take our divisor and we are going to multiply it by each of these numbers here in our boxes. So 12 times 1/10 is 1 and 2/10ths, and 12 times 1 we have 12, and 12 times 10 we have 120, and 12 times 100 we have 1,200. Now again, we just look at these numbers and we see which ones fit into 38, and once we get one that's too big, we know we're done and we can figure this out. So will 1.2 fit into 38? Absolutely. What about 12? Yes, it will. 120, that's too big, so we're going to cross that out, and our answer will go in the ones digit, which we did already confirm up top here when we found that our estimate is going to be pretty close to 4. Let's come into our question and we cross out our decimal. Then does 12 go into 3? No, it doesn't, but it will go into 38. 12 goes into 38 3 times. So I put that's 36. I have an opening there to add a 0, so my 3 becomes a 30. I subtract, and you get 24. Does 12 go into 24? Yes, indeed. Perfectly. Now we total up our partial quotient here on the side. 30 plus 2 is 32. However, if you look at both of our estimates, our answer should only be in the ones place, and it should be somewhere close to 4. So we need to go in and add our decimal point for a final answer of 3 2/10. Now let's take a look at our next question here. 3 400 divided by 16. On this one, I'm going to start down here with our magnitude estimate. So we're going to take our 16, our divisor, and we are going to multiply it by each of these numbers for our magnitude estimate. So 16 times 1/10 is 1 6/10. 16 times 1 is 16. 16 times 10 is 160. And 16 times 100 is 1,600. Okay, so now we need to look and see which one will fit. Will 1.6 go into 300 or 3 400? Yes, it will. Is 16 going to work? Actually, this time it's not. So this tells me that my answer is going to be rather small. And it's going to be that small, it's actually going to equal less than 1. So now we come up to our top estimate where we have our 3 400 divided by 16. And this is where, creating our estimate, we already know that it's going to be less than 1. Now how can I come up with an estimate this way to also show that? Well, I think of my 16, I'm going to keep that 16 first, and I need to think of a number that 16 will go into that's close to 3, and I'm kind of looking at it as a 30, and I know that 16 will go into 32, so what if I round this to 3.2? So 16 goes into 32 2 times, so if I look at my decimal, then I know from multiplying decimals, which we just went over, that it's actually going to be 0.2. So again, both of my estimates do match up, and it's telling me, hey, your answer is going to be much smaller than 1. All right, we take our problem, we ignore that decimal, we'll use our estimates to come back in and put that into the question. 16 does not go into 3, but it will go into 31 time. Now we have my 4 needs a number to go with it, so we add a 0. Make sure to add your 0 to the partial quotient. Let's do some subtraction here. We even get to borrow. And 10 minus 6 is 4, and 2 minus 1 is 1. Now here is where we can go ahead, we can look at this, and we can try to figure out, okay, how many 16s will go into 144? And we could do this a bunch of ways. I know that 16 times 10 is 160, so I know it's going to be pretty close to that. So what happens if I take 16 away? I might be onto something. Let's look. 10 minus 6 is 4, 5 minus 1 is 4, and 1 minus nothing. Look at that. So I've figured out that 16 times 9 will give me exactly 144. Put that in my partial quotient. Subtract it. Very nice. Now we add our partial quotient up and we get 19. But wait, our estimate said that this is going to need to be smaller than 1. So before we go ahead and put the decimal in, because this seems like where it goes every time, not exactly, we need to put our decimal in a spot that is going to make it less than 1. So that means it's going here, and when you do that, we need to add our 0. So it's actually going to be 1900. And now let's look down here. You probably guessed it already. It's now your turn. For my class, I would like you to go ahead, do each of these problems. You can do the estimate. If you'd like to do the magnitude estimate with the boxes, great. If not, you can do an estimate like I did up above, but we will need some sort of estimate and the actual answer.